So how do I convert? How do I go from degrees into radians and vice versa? Because I'm confused. Well, it's based on what you just learned. Think about it. Do you remember what 180 degrees was? Of course, that works out to be pi. So why don't you just set up a proportion? Watch. If I set up a proportion, that means this 30 degrees here goes here. This goes to x. We want to know how many radians it is. Well, you can do all that cross multiply stuff and all that other stuff and so on and so forth. But before you do that, try to simplify this side. See what it works out to be. If you take 180 degrees and you divide it by 30, look, cancel out the zeros. 18 divided by 3 is just plain old 6. So you got 6 equals to pi over x. Now, do the cross multiplication thing, right? That's 1. 1 times pi is just pi equals to 6x. Divide by 6, divide by 6. X works out to be pi over 6 radians. That's what it is, right? So 30 degrees is considered to be pi over 6 radians. Done. That's just way too easy. But some people will say, oh, no, I don't like that. I want a formula. Okay, well, if you go back to the formula, what I did on the previous podcast, which was right here, all the way down at the bottom, the formula was this mess. It was this mess, which basically said go from degrees, multiply it by this value. Okay, we can do that. Let's go to here. Let's do the second question. The second question is 315 degrees. How the heck do you do that? Well, according to that formula that I just gave you, you would take 315 degrees, you'd multiply this. Oops, let me just make that a multiply. There we go. You'd multiply this by, let's go back and let's take a look. See, it's way down here on the bottom. You'd multiply it by pi over 180. Okay, all right. Okay, well, multiply this by pi over 180, which would mean then you have 315 pi over 180, and now you're doing that reducing the fractions garbage. Well, honestly, why don't you just take 315 over 180 and put it in your calculator right now? Check this out. 315 over 180. Do the math frac thing. 315 divided by 180. I like fractions, and get into using fractions in this unit because you got to be good at it. You hit it, punch it. You get 7 over 4. Okay, so what does this mean? Well, this becomes 7 over 4 pi radians. So write it out. 7 over 4. And they like to leave the pi in there. You'll see it as 7 pi over 4 rather than 7 over 4 pi. They like to leave the pi in the numerator, okay? That's how you do that one. But I got another question for you. What if I'm one of those kind of people that I want to use dimensional analysis? Dimensional analysis means you don't have to memorize any kind of formula, means you don't have to memorize any kind of anything. You just got to use common sense. You just have to use common sense. Do you remember conversions? Do you remember conversions all the way back, going back to Math 10C? Let me show you what I mean by that. If you think about the conversions all the way back to Math 10C, you're thinking about things like kilometers per hour. And you would think about something like, centimeters to meters, right? Let's use the idea of an hours and days, okay? Very, very simple. You know that there's 24 hours in a day. So my question to you is, if I gave you 10 hours, what portion of the day is that? Simple. You know and I know, put hours on the bottom because that's what's going to cancel. You put days on top. You know and I know that this guy here, hours, would cancel with this. That would just make common sense. And you know that one day is 24 hours. So you know in order for this to cancel, you're going to have to divide the 10 by the 24. Well, why can't you do the same thing for radian conversions? You can do the same darn thing. Watch. I'm going to show you how easy it is for these two, A and B, and then we'll go on to C. Okay? 30 degrees. Think of the word degrees. Okay. Just in your typical dimensional analysis, what's got to go on the bottom then? Degrees has got to go on the bottom. Degrees, of course, is going to go on the bottom. What's going to go on the top? Radians. Okay. Now, what was the conversion? Do you remember? 1 pi radian is 180 degrees. So what you've got here then is you got 30 pi over 180. Check this out. Watch. It's so easy. 3 goes into 18 6 times. You have 1 pi over 6 radians. Done. That's it. That's simple. Really, really super simple. No formulas to memorize, no nothing. You just have to remember if you're going to cancel out the degrees on top has to cancel with the degrees on the bottom, and don't forget the conversion. And if you can't remember the conversion, real simple. Just go like this, draw a nice little unit circle, and remember all the way around is 2 pi, that's 360 degrees. Halfway around is pi, that's 180 degrees, and you're good to go. Watch again. This becomes really super, super simple. Here we go again. Let's do this with the 315, and then we'll carry on with the rest of the question. Okay? You ready? Here we go. 315. So think, you want 315 degrees, you want this in radians. Okay? So what goes on the bottom? Well, degrees goes on the bottom. What goes on the top? Well, radians goes on the top. Okay, think about it. Pi radians is 180 degrees. So multiply this straight across. 315 degrees times pi over 180 degrees. Notice a couple things. Degrees and degrees, of course, are going to cancel. 315 over 180, if you remember, was 7 over 4, and this would be 7 pi over 4, and there's your answer. It's that simple, that straightforward, right? So take a look at something like C. Now, in C, we don't really like the negativeness. So think about what negative means. Negative means instead of going this way, going around to 360 degrees, you went from here and you actually went backwards 225. So think about it. That's 180. It's got to be a little bit more. There's your 225, minus 225. But I got a question for you. Let's talk common sense. Is there a positive degree to this? And how would you find it? Of course there's a positive degree to that. That basically would be your 360 degrees. Take away this minus 225. Look, if this is 360 all the way around, right, you're going to take away this minus 225, you're going to get the positive value. Oh, well, that just makes sense. That works out, of course, to be 135 degrees. Sweet. Okay, so let's take that 135 degrees and convert it to radians. 135 degrees, okay? Don't forget, what goes on the bottom? Degrees goes on the bottom. What goes on the top? Radians goes on the top, okay? Pi radians is 180 degrees. Oh my goodness, how sweet and how beautiful. Degrees and degrees cancel, leaving you with 135 pi over 180. And if you don't like doing the conversions, if you can't do this in your head, pop up the calculator. There you go, 135 divided by 180, right? And then just math and hit the fraction, and you get the frac. There it is, 3/4. So you would write this down as, guess what? 3 pi over 4. That frac button on the calculator just saves your butt, hey? I tell you. Let's keep on going. Look at this one, okay? Now, notice how the other ones were really nice. This one that's telling you straight out, express it to the nearest tenth. So they want you to do this as a decimal. No problem. Let's use dimensional analysis. That's the easiest one to deal with. Okay, 70 degrees times. That would mean degrees is on the bottom. That means the rad's on the top. You know that pi rads is 180 degrees, right? And look, degrees and degrees cancel, leaving you 70 pi's over 180. Cancel that out. As a fraction, that would be 7 pi over 18. But they don't want it as 7 pi over 18. They want it as a decimal. They want it as a decimal. Okay, so here we go. Put this in your calculator. 7 pi over 18. Okay, so here we go. Bring up the fraction again. Boom. 7. And look, there's the pi button right there over 18, which works out to be 1.22. Oh, that's nice. And they want it, what did it say? To the nearest tenth. Okay, that's nice. I'll just say that this is 1.2 rads. Now, remember the unit circle thing? Remember the unit circle thing? That was a third, that was a third, that was a third, that was the 0.14. So 1.2 rads, if you think about it, is right around here or so. Well, that's about 70 degrees, isn't it? From about here to here, it's not quite 90, it's 70 degrees, 1.2 rads. Wow, is this fun now? The conversion part of this is super easy, super simple. Okay, so I'm going to put my answer back here, 1.2 rads. Okay, let's do the next one. Let's see if we can do this a little bit quicker. All right, 205. 205 degrees times, of course, oh, times. What's on the bottom? 180 degrees. What's on the top? Pi rads. Okay, they want this as a decimal, so this is going to be 205. Now, degrees and degrees cancel. 205 pi's over 180. All right, let's throw that in the calculator right now. Boom. Alpha, there it is. There's a fraction. We want our 205 on the top. Okay, 205 pi's, second pi, over the 180 degrees conversion. Boom, you get 3.577 or 3.6 rads. Okay, this works out to be 3.6 rads. Now, remember the unit circle. Remember? Okay, there was a rad right here. There was another rad right here. There was another rad. Now, how do you know that that's 3? Because that's pi over here, and that's your 0.1415, blah, 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 the rest of pi that you have to remember. So 3.6, well, there's 3.14 to this point, right? Look, 3.14 and 0.6 more, a little bit more, which is out here, and sure enough, that's where your 205 is. 205 degrees or your 3.6 rads. I want you to start thinking of these numbers in terms of rads. Why not? Okay, so let's do the last one in example 2. Okay, here we go. And then we're going to take a look at converting back in the next podcast. Okay, here we go. Minus 342. Ah, that's what negative stuff again. Ah, gosh. Okay, minus 342 means all the way back to here because you know all the way around is 360. So why don't we just subtract that from 360 and get a positive value? Okay, minus 342. All right. So that's going to be 8 from 5. That's going to be a whole rockin' 18 degrees. So it's going to be a very, very small angle of 18 degrees. Okay, let's figure out 18 degrees then as a rad. Okay, here we go. 18 degrees. On the bottom, of course, is your degrees, which is 180 degrees in 1 pi radian. Beautiful. Degrees and degrees cancel. Oh my goodness, really? This is going to give us 18 pi over 180. Look at that. This is going to be basically pi over 10. Oh, we can convert that into a decimal. No problem. And it says to the nearest tenth. Well, you know pi is 3.14. Divided by 10, this is going to be 0.314 onwards, but it only says to the nearest tenth. So you're actually going to be at 0.3 rads. All right, stay tuned for the next podcast, and we're going to go backwards.